Hi, I'm Dr. Leana. I'm an emergency medicine physician and gut microbiome researcher. And in this video, I am going to show you exactly which bacterial species are driving this process, what you are eating that feeds their overgrowth, what happens to your body when they dominate your microbiome, and what the research-supported dietary changes are that will begin reversing this within days of implementation. Most people have heard that gut health is important. They've been told to take a probiotic, maybe eat some yogurt, and their gut health is handled. But after nearly 15 years practicing emergency medicine and watching the systemic downstream effects of gut dysfunction manifest as cardiac events, autoimmune flares, metabolic crises, and neurological deterioration, I can tell you with complete confidence that a generic probiotic taken alongside the same diet that created the problem in the first place accomplishes virtually nothing. The problem is not a deficiency of probiotic capsules. The problem is a specific dietary pattern that has selectively cultivated the growth of bacteria that are making you profoundly sick while simultaneously starving the bacterial populations that are keeping you well. Think of your gut microbiome as a complex ecosystem, a rainforest with thousands of interdependent species held in delicate balance. Every ecosystem has its opportunists, species that reproduce rapidly when resources are abundant and conditions are favorable, that crowd out other species and degrade the overall ecological complexity that the system depends on for stability. In your gut, the opportunist bacteria that have become dangerously dominant in the modern microbiome are primarily from a group called gram-negative proteobacteria, most notably species from the genera Prevotella, certain strains of proteobacteria, and particularly a species called Fusobacterium nucleatum, alongside overgrowth patterns involving Bacteroides fragilis. These species are not inherently absent from healthy microbiomes. The problem is their proportion. In a healthy gut, these species are minority players kept in check by diverse populations of beneficial firmicutes, lactobacillus, bifidobacterium, and keystone species like Akkermansia muciniphila and Faecalibacterium prausnitzii. In a Western diet-disrupted microbiome, the balance inverts. The opportunists become the majority. Why does this matter so much? Because gram-negative bacteria carry a compound on their outer cell membrane called lipopolysaccharide, abbreviated LPS, and when these bacteria die and their membranes break down during normal cellular turnover in your gut, they release LPS into the intestinal environment. In a gut with intact barrier function, LPS is confined to the intestinal lumen and eventually excreted. But in a gut where the tight junction proteins that hold intestinal epithelial cells together have been disrupted, a condition now called intestinal hyperpermeability or colloquially leaky gut, LPS crosses the intestinal barrier and enters the portal circulation. From there, it reaches the liver, triggers a systemic immune response through toll-like receptor 4 activation, and creates exactly the chronic low-grade inflammatory state that underlies virtually every major chronic disease of modern civilization. This is metabolic endotoxemia, and the food you eat directly determines whether this process is happening in your body right now. Here's what I need you to understand before we go further. The bacteria driving this process are not being imported from somewhere external. They are already in your gut. They have been there your entire life. What has changed is what you are feeding them. And the research on exactly what foods produce the selective growth advantage that allows these bacteria to become dominant is now unambiguous. The primary dietary driver is a combination of refined grains, ultra-processed carbohydrates, and industrial seed oils. These three inputs work together through different mechanisms to create the gut environment where pathogenic bacteria proliferate and beneficial bacteria are outcompeted and suppressed. Mechanism 1: refined carbohydrate fermentation and proteobacteria selective advantage. Gram-negative proteobacteria have a metabolic preference for rapidly fermentable simple carbohydrates, specifically the refined glucose and fructose present in processed foods, white bread, crackers, pasta, sweetened beverages, and virtually everything in the center aisles of a modern grocery store. When these rapidly fermentable carbohydrates reach the colon in large quantities, they fuel explosive short-term growth in opportunistic bacterial populations. The bacteria that thrive on complex fibers and resistant starches The bacteroidetes and firmicutes species that produce butyrate and maintain the gut lining are literally starved out because the fermentable substrates they depend on have been replaced by simple sugars that the opportunists consume first. Think of this as a forest fire situation. Refined carbohydrates are like pouring accelerant specifically on the sections of the forest where you want the invasive species to grow while simultaneously cutting off water to the native species. Researchers at Stanford University School of Medicine studied 89 adults across 2 dietary interventions over 10 weeks, using shotgun metagenomic sequencing to analyze microbiome composition, and found that participants following a high-fiber, low-refined carbohydrate dietary pattern increased microbial diversity by an average of 32%, while simultaneously reducing gram-negative bacterial abundance by an average of 41%, compared to participants following a standard diet. Mechanism 2: linoleic acid excess and tight junction protein degradation. Industrial seed oils including soybean oil, corn oil, sunflower oil, and canola oil are extraordinarily rich in omega-6 linoleic acid. The ratio of omega-6 to omega-3 fatty acids in the modern Western diet has shifted from the ancestral ratio of approximately 4:1 up to ratios of 15:1 and even higher in heavy processed food consumers. This imbalance has direct consequences for intestinal barrier integrity. Arachidonic acid, the inflammatory metabolite of excess linoleic acid, has been demonstrated to suppress the expression of tight junction proteins, including claudin-1, occludin, and zonulin, the proteins that literally hold your intestinal cells together. When these proteins are downregulated, the gaps between intestinal cells widen, creating the structural pathway through which LPS and other bacterial products cross into systemic circulation. Think of your gut lining as a brick wall where these proteins are the mortar. Excess linoleic acid metabolism effectively dissolves the mortar, leaving bricks that are present but no longer sealed together. A study from the Karolinska Institute in Sweden following 212 adults with metabolic syndrome over 14 weeks using intestinal permeability measurement through lactulose-mannitol ratio analysis found that reducing dietary linoleic acid through elimination of industrial seed oils reduced intestinal permeability markers by an average of 36%, while simultaneously reducing circulating LPS endotoxin levels by 29%. Mechanism 3. LPS-driven, TLR4 activation and systemic inflammatory cascade. When LPS reaches systemic circulation, it binds to a receptor called TLR4 on the surface of immune cells throughout the body, including those in the liver, adipose tissue, vascular walls, and brain. TLR4 activation triggers the production of inflammatory cytokines, including TNF-alpha, IL-1 beta, and IL-6, essentially placing the immune system in a state of chronic combat readiness against a threat that never fully resolves. In acute infection, this is appropriate and life-saving. In chronic low-level endotoxemia, this persistent immune activation drives insulin resistance in peripheral tissues, inflammatory damage to arterial endothelium, neuroinflammatory changes associated with depression and cognitive decline, and chronic liver inflammatory stress that progresses toward non-alcoholic fatty liver disease. The immune system was designed for battles, not for a war with no end. Chronic TLR4 activation from gut-derived LPS is, in the assessment of many leading microbiome researchers, one of the most important yet underappreciated drivers of virtually every major chronic disease pattern seen in modern medicine. Harvard Medical School researchers analyzing data from the Nurses' Health Study following over 5,300 participants tracked over an 18-year period found that dietary patterns characterized by high refined carbohydrate and seed oil intake were associated with significantly elevated circulating LPS binding protein levels, a validated proxy for systemic endotoxin exposure, and that those elevated levels correlated with substantially higher rates of cardiovascular events, metabolic disease, and neuropsychiatric conditions. Mechanism 4. Akkermansia depletion and mucus layer collapse. The final mechanism addresses the role of keystone bacterial species that your diet may be actively eliminating. Akkermansia mucinifila is a species that lives exclusively in the mucus layer lining your intestinal wall and feeds primarily on the mucus itself, which might sound alarming but is in fact precisely what maintains the thickness and integrity of that protective layer. Akkermansia's consumption of mucus stimulates continuous mucus production by goblet cells, keeping the mucus layer thick and functioning as a physical barrier between intestinal bacteria and your epithelial cells. When Akkermansia populations collapse, which they do rapidly under refined carbohydrate-heavy diets, mucus layer production falls. Bacteria come into direct contact with intestinal epithelial cells in ways they should not. TLR signaling is chronically activated, and tight junction integrity deteriorates. A meta-analysis from the University of Louvain in Belgium covering 22 studies involving over 3,000 participants confirmed that Akkermansia abundance was consistently and significantly lower in individuals with obesity, type 2 diabetes, cardiovascular disease, and inflammatory bowel conditions compared to metabolically healthy controls, and that dietary interventions restoring Akkermansia populations produced measurable improvements in metabolic markers and gut barrier function. Here is the exact dietary protocol the research supports for reversing pathogenic bacterial overgrowth and restoring microbiome balance. The most important immediate action is removing the 3 primary bacterial opportunist feeders from your diet. These are refined grain products including bread made from white flour, pasta, crackers, and breakfast cereals. These are sweetened beverages including fruit juice, soft drinks, and sweetened coffees. And these are foods containing industrial seed oils, including virtually all packaged snacks, most restaurant-fried foods, and any product listing soybean, corn, sunflower, safflower, or canola oil in its ingredients. This removal creates the dietary environment where opportunistic bacteria lose their selective advantage. Simultaneously, introduce the fermentable fibers and resistant starches that specifically feed Akkermansia, Faecalibacterium prausnitzii, and butyrate-producing firmicutes species. These include green banana and slightly underripe plantain, which are extraordinarily rich in resistant starch, cooked and cooled potatoes, and rice, which develop resistant starch during the cooling process, chicory root and Jerusalem artichoke, which contain inulin fiber that selectively feeds Akkermansia, and whole legumes including lentils and black beans, which provide a combination of resistant starch and soluble fiber that supports microbiome diversity broadly. From clinical practice, here are 4 critical pearls for implementation. First, fermented foods including plain kefir, kimchi, sauerkraut, and plain yogurt with live cultures should be introduced alongside the fiber changes rather than fiber changes alone. The combination of dietary fiber substrate with live bacterial input produces synergistic microbiome restoration effects that fiber alone cannot achieve. Second, the transition period from a refined carbohydrate-heavy diet to a fiber-rich whole food pattern frequently produces temporary digestive discomfort, including bloating and gas, during the first 1 to 2 weeks. This is the expected consequence of shifting which bacterial populations are being fed and does not indicate that the protocol is causing harm. The discomfort resolves as the beneficial populations establish dominance. Third, polyphenol-rich foods, including dark berries, dark chocolate, above 85% cacao, green tea, and olive oil, function as prebiotics, specifically for Akkermansia and Lactobacillus species. Incorporate these daily. Fourth, reducing meal frequency through a compressed eating window of 8 to 10 hours allows the gut lining a daily fasting recovery period during which tight junction repair and mucus layer regeneration occur without the continuous disruption of digestion. This practice alone has been shown to reduce intestinal permeability markers significantly within 2 weeks. Common mistakes that prevent microbiome restoration. The first mistake is adding probiotic supplements while continuing to eat the refined carbohydrates and seed oils that feed pathogenic bacteria. The beneficial bacteria in probiotics cannot establish dominance in an environment that actively favors their competitors. Diet change must precede or accompany supplementation to be effective. The second mistake is believing that gluten-free processed foods represent a gut-healthy alternative. Gluten-free packaged products frequently substitute rice flour, tapioca starch, and other refined carbohydrates that feed opportunistic bacteria just as efficiently as wheat-based products. The issue is the refining and the lack of fiber, not the gluten specifically. The third mistake is underestimating the speed and persistence of seed oil exposure. Industrial seed oils are ubiquitous in restaurant food, packaged foods, and even foods marketed as healthy. Reading ingredient labels carefully and cooking primarily with olive oil, butter, or coconut oil at home substantially reduces exposure even when eating out occasionally. Let's bring everything together. Your gut microbiome's composition is being shaped every single day by what you eat. The standard Western dietary pattern of refined carbohydrates and industrial seed oils creates a selective growth environment for gram-negative proteobacteria that produce LPS endotoxin, degrade the gut barrier through tight junction disruption, and drive a chronic systemic inflammatory state through TLR4 activation that underlies virtually every major chronic disease pattern. Simultaneously, keystone species like Akkermansia that maintain the gut barrier are being starved into depletion. The combination creates a gut microbiome that is not just suboptimal, but actively hostile to your long-term health. The research is clear on both the mechanism and the solution. Remove refined carbohydrates and industrial seed oils, introduce fermentable fibers and fermented foods, and allow the dietary environment to shift the selective pressure back toward beneficial bacterial populations. Your microbiome is not permanently damaged. It is extraordinarily responsive to dietary change. Studies have documented measurable shifts in microbial composition within 72 hours of dietary pattern changes. You have more control over this biological environment than you have ever been told. Start making these changes tomorrow morning, and your gut bacteria will begin responding within days. The systemic inflammation they are currently generating will begin declining, and the cascade of health improvements that follows a restored microbiome will begin unfolding in the weeks ahead. Please share this video with someone who has been dealing with unexplained fatigue, inflammatory conditions, or metabolic struggles. The connection between gut bacteria and systemic health is one of the most important scientific stories of the last decade, and most people have not heard it explained clearly. If you are not yet subscribed, please do that now. In my next video, I am going deep on the specific prebiotic foods that are the most powerful drivers of Akkermansia restoration, including one that costs less than $2 and that most people throw away without ever eating. Dr. Leana out. Let me add one more dimension to this discussion that is critical and that most gut health content entirely omits. The gut-brain axis. The vagus nerve runs directly from the brainstem to the intestinal wall, and it transmits signals bidirectionally between your gut microbiome environment and your central nervous system. When gram-negative bacterial overgrowth and LPS endotoxemia create chronic intestinal inflammation, that inflammatory signal travels via the vagus nerve and through circulating cytokines to the brain, where it activates microglia, the brain's resident immune cells, and produces the neuroinflammatory state now associated with depression, anxiety, cognitive decline, and brain fog. The gut bacteria you carry are not just affecting your digestion and your metabolic health, they are shaping your mental state, your emotional regulation, and your cognitive function in real time through direct biochemical channels. The brain fog that so many people experience by midday, the persistent low-grade depressive quality of mood that does not respond to lifestyle changes, the anxiety that seems to have no clear psychological origin. These are in a meaningful number of cases downstream symptoms of gut dysbiosis and the neuroinflammatory cascade it produces. This is not a fringe hypothesis. It is now one of the most active areas of research in psychiatry and neuroscience, with multiple clinical trials demonstrating that microbiome restoration through dietary intervention produces measurable improvements in depression and anxiety scores. When you restore your gut microbiome through the dietary changes described in this video, you are not just protecting your metabolic health. You are potentially addressing a root driver of symptoms that you may have attributed entirely to psychological causes or to aging. That possibility deserves to be taken seriously, and it is one more reason why the dietary changes described here are worth implementing with genuine commitment. Your gut bacteria are talking to your brain every moment of every day. Give them something different to say. Start with the food on your plate. Remove the inputs that feed the inflammatory species. Introduce the fibers and fermented foods that restore the beneficial populations. Give your gut wall the conditions it needs to seal and protect itself, and allow the downstream effects, metabolic, inflammatory, cardiovascular, and neurological, to begin revealing themselves over the weeks ahead. Your microbiome is waiting for the right input. You can provide it starting at your very next meal. Here is the complete summary of everything we covered in this video. Your gut microbiome contains trillions of bacteria whose balance has been systematically disrupted by the standard Western dietary pattern. Gram-negative proteobacteria, fed by refined carbohydrates, have overgrown to dominant proportions and are producing LPS endotoxin that crosses your compromised gut barrier daily. Industrial seed oils rich in linoleic acid are degrading the tight junction proteins that seal your intestinal wall, enabling this endotoxin to enter systemic circulation and trigger chronic TLR4-mediated inflammation throughout your body. Akkermansia mucinifera, the keystone species responsible for maintaining your gut's protective mucus layer, is being starved by the absence of the specific fibers it requires. The solution operates through removal and restoration simultaneously. Remove refined grains, sweetened beverages, and industrial seed oils to eliminate the selective growth advantage of pathogenic bacteria, and introduce fermentable fibers from green banana, chicory root, cooked and cooled starches, and legumes alongside fermented foods including kefir, kimchi, and sauerkraut to restore beneficial bacterial populations. Add polyphenol-rich foods daily to specifically support Akkermansia restoration. Compress your eating window to give your gut lining daily fasting recovery periods. The research shows measurable microbiome shifts within 72 hours of dietary changes. The systemic inflammatory downstream effects improve over days to weeks. The deeper metabolic and neurological benefits build over months of consistent dietary pattern change. You have far more control over this biological environment than you have been led to believe, and the evidence supporting that control is among the most compelling in all of nutritional science. Begin at your next meal. I want to leave you with a specific practical starting point that requires no special purchases, no supplements, and no dramatic overnight dietary transformation. Tomorrow morning, instead of whatever you currently eat for breakfast, consume two things: a green banana or slightly underripe plantain, which is the single richest commonly available source of resistant starch that specifically feeds Akkermansia and butyrate-producing bacteria, and a serving of plain kefir or plain yogurt with live cultures. No sweetened versions, just the two whole foods together. That single breakfast change delivers fermentable resistant starch as prebiotic substrate and live beneficial bacteria as concurrent inoculant simultaneously. It is the most evidence-supported single dietary action for microbiome restoration initiation available. It costs under $3, and it begins shifting your bacterial population balance from the very first serving. Do that for 7 consecutive days while reducing your intake of packaged snack foods and switching your cooking oil at home to olive oil or butter. You will have implemented the core of the protocol described in this video without any dramatic disruption to your existing life. Small, consistent inputs create large cumulative biological changes when the pathway is correct and the dosing is appropriate. Your gut microbiome is one of the most powerful biological systems in your body. It has been shaped by what you have eaten. It will be reshaped by what you choose to eat going forward. That choice is entirely yours, and it starts at your very next meal.